How man produces heavy-duty trucks daily, inside the European truck factory, full process. Welcome to one of the most advanced truck manufacturing facilities in Europe, where giant machines, robotic precision, and human engineering come together to build some of the world's most powerful heavy-duty trucks. Today, we are taking you deep inside the incredible world of man truck production. From raw steel to fully assembled highway monsters, you will witness every stage of the process that transforms thousands of components into reliable heavy-duty transport machines trusted across Europe and beyond. Every single day, these factories produce massive trucks designed to carry enormous loads across long distances, survive harsh weather conditions, and operate continuously for years. But building a truck is not simply about putting parts together. It is a complex engineering process involving precision manufacturing, advanced robotics, quality testing, and highly skilled workers coordinating every detail. The story begins long before the first bolt is tightened. It starts with design engineers who spend years developing safer, stronger, and more efficient truck platforms. These trucks must meet strict European standards for emissions, fuel economy, safety, and durability. Every curve of the cab, every engine component, and every electronic system is carefully engineered using advanced computer simulations before production even begins. Once the design phase is completed, production starts with raw materials arriving at the factory. Massive steel coils and aluminum sheets are delivered daily to the press shop, where the truck's body panels are formed. Gigantic hydraulic presses shape these metal sheets into doors, roof sections, side panels, and structural components. The pressure generated by these machines is unbelievable. With just one powerful movement, flat steel becomes a perfectly shaped truck body part. Inside the press shop, automation plays a major role. Robotic arms move metal sheets from one station to another with incredible speed and accuracy. Sensors continuously monitor alignment to ensure every component meets exact specifications. Even the smallest error could affect the truck's structural integrity later in production. After the panels are formed, they move into the body shop, one of the most fascinating sections of the factory. This is where hundreds of robots work together like a synchronized orchestra. Sparks fly in every direction as robotic welding arms join metal sections together to create the truck cab structure. Each welding robot performs thousands of welds every day with extreme precision. Unlike manual welding, robotic systems ensure consistency and strength across every truck produced. Cameras and laser measuring systems constantly check positioning during the welding process. The result is a perfectly aligned cab frame capable of surviving years of heavy-duty use. Despite the high level of automation, human workers remain essential throughout the production process. Skilled technicians supervise robotic operations, inspect weld quality, and handle complex assembly tasks that still require human expertise. The collaboration between humans and machines is what makes modern truck manufacturing so efficient. Once the cab frame is completed, it enters the paint shop, one of the most technologically advanced and environmentally controlled areas in the factory. Before painting begins, the cab undergoes extensive cleaning and anti-corrosion treatment. Special chemical baths remove impurities and protect the metal from rust. Corrosion protection is extremely important because these trucks operate in rain, snow, mud, and harsh road conditions for many years. European truck manufacturers invest heavily in rust prevention technologies to ensure long-term durability. After cleaning, the cab receives multiple layers of primer and paint. Robotic painting systems apply the coating evenly with remarkable accuracy. These robots can paint complex surfaces while minimizing paint waste and environmental impact. The factory uses advanced filtration systems to reduce emissions and recycle excess materials whenever possible. The paint then passes through giant curing ovens where high temperatures harden the finish into a durable protective coating. Once completed, the cab shines with a flawless finish ready for final assembly. Meanwhile, in another section of the factory, engine production is taking place. This is where the heart of the truck is born. MAN heavy-duty engines are designed for power, fuel efficiency, and reliability. Building these engines requires extremely precise machining processes. Engine blocks are manufactured using high-strength metal alloys capable of withstanding enormous heat and pressure. Computer-controlled machines cut, drill, and polish engine components with microscopic precision. Every measurement must be perfect because even tiny imperfections can affect performance and durability. After machining, engine components move to the assembly line where technicians carefully install pistons, crankshafts, camshafts, fuel systems, and turbochargers. Modern heavy-duty diesel engines contain thousands of individual parts working together under extreme conditions. Each completed engine undergoes rigorous testing before installation into a truck chassis. Engineers run the engines under simulated operating conditions to measure power output, fuel efficiency, emissions, temperature control, and vibration levels. Only engines that pass every test move forward in the production process. At the same time, chassis assembly begins in another area of the plant. The chassis serves as the truck's backbone, supporting the engine, cab, transmission, suspension, and cargo load. Heavy-duty truck chassis are incredibly strong because they must handle massive weights across long distances without structural failure. Large steel frame rails move along automated assembly lines where robotic systems and workers install cross members, fuel tanks, brake systems, air suspension components, and electrical wiring. Every chassis configuration may vary depending on the truck's intended purpose. Some are designed for long-haul transportation, while others are built for construction, mining, or specialized industrial operations. One of the most critical systems installed during chassis assembly is the braking system. Modern European trucks use advanced air brake technology combined with electronic safety systems. These systems help drivers maintain control during emergency braking situations and reduce accident risks on highways. Next comes transmission installation. Heavy-duty truck transmissions are engineered to manage enormous torque produced by diesel engines. Modern automated gearboxes improve fuel efficiency while reducing driver fatigue during long journeys. Some trucks feature intelligent shifting systems that automatically adapt to road conditions and driving styles. As the chassis continues moving down the line, axles and suspension systems are added. These components are designed to absorb heavy impacts from rough roads while maintaining stability and comfort. Engineers carefully balance durability, weight distribution, and ride quality to maximize performance. Eventually, one of the most exciting moments in the production process arrives: the marriage station. This is where the painted cab, fully assembled chassis, engine, and drivetrain finally come together as one complete truck. Huge automated lifting systems carefully lower the cab onto the chassis with millimeter precision. Once connected, technicians begin installing the interior components. Inside the cab, workers fit seats, dashboards, steering systems, infotainment screens, climate control units, and electronic control modules. Modern truck cabins are far more advanced than many people realize. They function almost like mobile offices and living spaces for drivers who spend days or weeks on the road. Comfort is extremely important in long-haul trucking. Man-engineers design ergonomic seats, advanced suspension systems, sound insulation, and digital displays to reduce driver fatigue and improve safety. Some premium models even include beds, refrigerators, storage compartments, and sophisticated entertainment systems. The wiring process alone is incredibly complex. Modern heavy-duty trucks contain kilometers of electrical wiring connecting hundreds of sensors and electronic systems. These systems monitor everything from fuel consumption and tire pressure to engine temperature and driver assistance technologies. Advanced driver assistance systems are now standard in many European trucks. Features such as adaptive cruise control, lane departure warning, emergency braking assistance, blind spot monitoring, and camera systems help improve road safety and reduce accidents. After interior installation, the truck undergoes fluid filling operations. Technicians add engine oil, coolant, transmission fluid, brake fluid, and diesel fuel before performing initial startup procedures. This is often the first time the truck's engine roars to life inside the factory. The moment the engine starts is a critical milestone. Engineers carefully monitor pressure levels, electronic systems, exhaust emissions, and engine performance during initial activation. Diagnostic computers instantly detect any irregularities requiring correction before the truck proceeds further. But production is still far from complete. Every finished truck must pass extensive quality inspections and performance testing before delivery. European manufacturers maintain extremely strict quality standards because heavy-duty trucks operate in demanding commercial environments where reliability is essential. One of the first quality control stages involves computerized inspection systems. Cameras and laser scanners analyze body alignment, paint quality, component positioning, and assembly precision. Even tiny imperfections can trigger additional inspections or repairs. Next comes electrical testing. Technicians verify that every light, sensor, switch, display, and electronic system functions correctly. Modern trucks contain highly advanced onboard computers managing engine performance, safety systems, and driver assistance technologies. Any software issue must be resolved before shipment. The truck then moves to water testing chambers where powerful jets simulate heavy rain conditions. Engineers inspect the cab for leaks to ensure drivers remain comfortable and protected during bad weather. Brake testing is another extremely important stage. Trucks are placed on rolling dynamometers where braking systems are evaluated under simulated driving conditions. These tests measure stopping power, balance, response time, and system reliability. Engine performance testing follows next. Trucks are connected to diagnostic systems that simulate real-world driving conditions while monitoring emissions, fuel efficiency, acceleration, and thermal performance. European emissions standards are among the strictest in the world, forcing manufacturers to develop highly advanced diesel technologies. Noise and vibration testing also play a major role in modern truck manufacturing. Engineers work continuously to reduce cabin noise and improve driving comfort. Sophisticated insulation materials and precision engineering help create quieter cabins for drivers spending long hours behind the wheel. After passing indoor testing, completed trucks often undergo road testing outside the factory. Professional test drivers take the vehicles onto specially designed tracks or public roads to evaluate steering, braking, suspension, acceleration, and overall handling performance. During these road tests, engineers analyze real-time data collected by onboard sensors. They monitor fuel consumption, engine temperature, transmission behavior, braking efficiency, and aerodynamic performance. Every truck must meet strict operational standards before receiving final approval. Once testing is complete, trucks move to the finishing area where final details are added. Company logos, badges, protective coverings, and customer-specific accessories are installed. Some trucks are customized according to client requirements, including specialized trailers, heavy-duty equipment, additional fuel tanks, or unique cabin configurations. Large logistics operations then begin preparing the trucks for delivery across Europe and international markets. Some trucks are transported by rail, while others leave the factory under their own power driven by professional delivery drivers. The scale of these manufacturing operations is astonishing. Thousands of workers, engineers, suppliers, robots, and computer systems cooperate every day to maintain continuous production. Supply chains deliver enormous quantities of components precisely when needed, allowing factories to operate efficiently with minimal delays. Modern truck factories are also becoming increasingly sustainable. European manufacturers invest heavily in reducing emissions, energy consumption, and waste production. Many facilities use renewable energy sources, advanced recycling systems, and environmentally friendly manufacturing technologies. Electric and hydrogen-powered trucks are now becoming part of the future production strategy as well. While diesel engines still dominate heavy-duty transportation, manufacturers are rapidly developing alternative powertrains to meet future environmental regulations and sustainability goals. Inside research and development departments, engineers are already testing autonomous driving systems, connected fleet technologies, and next-generation battery solutions. The trucking industry is entering a new technological era where efficiency, automation, and sustainability will play bigger roles than ever before. However, despite all the technological advancements, one thing remains unchanged: the importance of reliability. Truck operators depend on these machines for business operations, cargo delivery, and global trade. A single truck may travel millions of kilometers during its lifetime, carrying everything from food and medicine to construction materials and industrial equipment. That is why manufacturers like MAN focus heavily on durability testing during development. Prototype trucks are subjected to extreme heat, freezing temperatures, rough terrain, steep mountain roads, and continuous stress testing. Engineers intentionally push vehicles beyond normal operating conditions to identify weaknesses before mass production begins. Safety is another major priority. European truck manufacturers continuously develop stronger cabins, smarter braking systems, improved visibility technologies, and advanced collision prevention systems. Every improvement aims to protect both drivers and other road users. The evolution of truck manufacturing over the decades has been incredible. Early truck factories relied heavily on manual labor and basic mechanical tools. Today, artificial intelligence, robotics, laser measurement systems, and digital manufacturing technologies dominate the production environment. Factories now use smart manufacturing systems capable of tracking every component throughout the production process. Digital monitoring systems instantly detect inefficiencies, improve quality control, and optimize assembly operations in real time. Some factories even use automated guided vehicles that transport parts across production floors without human drivers. These intelligent transport systems improve efficiency while reducing workplace accidents and operational delays. Data analysis also plays a major role in modern manufacturing. Sensors installed throughout the factory collect enormous amounts of information about machine performance, energy consumption, assembly speed, and product quality. Engineers use this data to continuously improve productivity and reduce manufacturing costs. Training workers for these advanced factories requires significant technical expertise. Employees must understand robotics, computer systems, automation technology, and precision manufacturing techniques. Modern truck factories combine traditional mechanical engineering with advanced digital technology. The result of all this innovation is a truck capable of performing some of the toughest transportation jobs on Earth. Whether crossing European highways, operating in construction sites, or hauling cargo across international borders, these machines are designed to work under extreme conditions every single day. Heavy-duty trucking remains one of the most essential industries in the modern world. Nearly everything people use daily has likely been transported by truck at some point. Food, electronics, machinery, fuel, medical supplies, and construction materials all depend on reliable freight transportation systems. Without these powerful machines, modern economies would struggle to function efficiently. That is why manufacturers continue investing billions into improving truck technology, safety, fuel efficiency, and production methods. Watching the complete manufacturing process reveals just how much engineering expertise and industrial coordination is required to build a single heavy-duty truck. From raw steel to final road testing, every stage demonstrates the incredible complexity of modern vehicle production. Inside these European factories, precision, automation, and human skill combine to create machines capable of traveling across continents while carrying enormous loads safely and efficiently. Every weld, every bolt, every software system, and every quality inspection contributes to the final product rolling off the assembly line. And as technology continues evolving, the future of truck manufacturing promises even more innovation. Electric drivetrains, autonomous systems, hydrogen fuel technology, and smart logistics networks will reshape the industry over the coming decades. But no matter how advanced these trucks become, the goal will always remain the same: building reliable machines that keep the world moving. This was the incredible full process of how man produces heavy-duty trucks daily inside one of Europe's most advanced truck factories. From robotic welding and precision engine assembly to final testing and delivery, every stage showcases the extraordinary scale of modern industrial manufacturing. If you enjoyed this behind-the-scenes journey inside the truck factory, imagine the thousands of engineering hours, advanced machines, and skilled workers required to produce these giants every single day. The next time you see a heavy-duty truck on the highway, you will know the incredible process that brought it to life. How man produces heavy-duty trucks daily inside the European truck factory, full process. Welcome to one of the most advanced truck manufacturing facilities in Europe, where giant machines, robotic precision, and human engineering come together to build some of the world's most powerful heavy-duty trucks. Today, we are taking you deep inside the incredible world of man truck production. From raw